Myself Vikas Kumar. Today I am going to teach periodic classification of elements for JEE Advanced previous year questions. So watch my video carefully. First question: which of the following has maximum number of unpaired electron? In these given options, in which metallic cations maximum number of unpaired electrons are present? With the help of electronic configuration, with the help of box diagram electronic configuration, we can solve this question. So, in case of NH2, here paired electron present. In case of NP6, in case of ND10, in case of ND10, in case of NF14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so now one by one. In case of magnesium, atomic number 12, 1s2, 2s2, 2p6 and 3s2. First cell, second cell, last cell. Due to presence of two positive charge, magnesium lose 2 electrons from their last cell. So 3s2 become 3s0. Okay. So 0 unpaired electronic present, because in S2 paired, S2 again paired, and P6 again paired. So no unpaired electron in magnesium double plus cation. Option B, titanium. Titanium atomic number 22, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d2. First, second, third and fourth. Now, triple positive charge present at titanium. So, due to triple positive charge, titanium release 3 electron from last cell. 4s2 become 4s0 and 3d2 become 3d1. So 3d1 is here, and box diagram of 3d1 is this. So only one unpaired electron present, only one. Now in case of vanadium, option C, atomic number 23, 1s2, 2s2, 2p6, 3s2, 3p6, okay, 4s2 and 3d3. So due to presence of 3 positive charge, vanadium release 3 electrons from their last cell. So 4s2 become 0 and 3d3 become 3d2. So we can write 3d2 here. Now in case of 3d2, only 2 electrons present, unpaired electron. Okay, in case of vanadium, triple positive. Now in case of iron, option D, in case of iron, atomic number 26, 1s2, 2s2, 2p6, 3s2, 3p6, okay, 4s2 and 3d6. Okay. Now due to presence of 2 positive charge, due to presence of 2 positive charge, 4s2 become 0. So last cell configuration of 3d6. In 3d6, 1, 2, 3, 4 unpaired electron present. Okay. So 4 electron is present here, 2 is present here, 1 is present here, 0 is present. Now we can observe maximum number of electrons present in iron double positive. So option D is correct. Now question number 2 is based on calculation of atomic radius and ionic radius. Question number 2 is which of the following has largest ionic radius? Options are given. In these cations and anions, maximum size of ionic radius present in which option? So I am going to solve this question. In case of lithium cation, 1s2 2s0. In case of boron, atomic number 5, 2 positive charge, 1s2 2s1 2p0. Now in case of O2 double minus, means O plus O negative plus O negative. So we can write electronic configuration of O single negative, atomic number 8, 1s2 2s2 2p5. Okay. Now in case of fluoride, 9 plus 1 10 electron, 1s2 2s2 2p6. Okay. Now from basic concept of atomic radius, in same period lithium, after that beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, left to right, with increase their atomic size decrease with increase in their atomic number. So on the basis of this concept, largest atomic size decrease left to right and atomic size increase right to left. Whenever they are converted into ions, then we can get change something in order of size. But in case of O2, in O2 double minus, O minus plus O minus. So for calculation of their ionic radius, we can add radius of oxygen single minus and oxygen single minus. So in these four options, in option B, large atomic radius present in O2 double minus. So we can take a screenshot. Now question number 3 is completely based on size of cations and anions. According to question number 3, which one of the following is a smallest size? 4 cations and anions are given. In which cations or anions size is minimum? Now here nitrogen in form of nitride, oxygen in form of oxide, fluorine in form of fluoride, and sodium in form of cation. So their atomic number is 7, 8, 9 and 11. Electronic configuration 1s2, 2s2 and 2p6. Here electron is 7 plus 3 10. Here 8 plus 2 10. So 1s2, 2s2 and 2p6. 9 plus 1 10. 1s2, 2s2 and 2p6. 11 minus 1 10. 1s2, 2s2 and 2p6. Now in these options, here we can draw 2 cells. Okay, and in case of nitrogen, 7 positive charge attract from last cell. Electron is weight 8, 8 and 8 respectively, so 8 electrons. In case of nitride, in case of oxide, 8 positive charge attract last cell. How much electrons? 8 electrons. Okay, 8 electrons. In case of fluoride, 9 positive charge. 9 positive charge attract 8 electrons. In case of sodium, 11 positive charge attract 8 electrons. Here, last cell is second, and nuclear charge top to bottom become increase. So maximum contraction occurs in case of sodium. So in given options, according to question, a smallest size. So due to maximum contraction, a smallest size is occurs in sodium cation. So option D is correct. You can take a screenshot. Now question number 4 is completely based on Lewis acid base concept. According to this question, which one of the following is the strong base? These options are given, and in which option, in these options, which one is a strong base? According to Lewis acid base concept, okay, LP acceptor central atom molecule is acid, LP donor central atom of molecule is base. So LP acceptor is acid and LP donor central atom present in molecule and molecule present basic character. So according to given these options here, nitrogen, hydride of nitrogen, here nitrogen, phosphorus, arsenic and antimony, all are members of group 15, and last cell configuration is 2s2, 2p3, 3s2, 3p3, 4s2, 4p3, 5s2, 5p3. In case of their hydride, ammonia, phosphine, here these are the given options, and in case of nitrogen, 2d is not present here. So all are p block element, and valence electron is 7, not 7, 3 plus 2 5, 5, 5 and 5. Okay. Now valency is 8 minus 5 is equal to 3. So in ground state valency is 3, 3, 3 and 3. But in excited state, due to large size of last cell, valency become changed. Nitrogen in ground state and excited state valency only 3. But in case of phosphorus, arsenic and antimony, due to change in size, valency become changed. So only ammonia have capacity to donate lone pair, okay, and due to lone pair donor tendency of central atom of ammonia, option B is correct. Ammonia is a strong base in compare with these 4 options. Option B is correct. You can take a screenshot. Now question number 5 is completely based on order of electronegativity. So according to this question, the electronegativity of the following elements increases in the order. In these 4 options, which one is correct? Which option show increasing order of electronegativity of elements? Now electronegativity inversely proportional to atomic size or atomic radius R. Okay. Now in case of carbon and nitrogen, atomic number 6 and 7 respectively, last cell electronic configuration 2s2 and 2p2, 2s2, 2p3. These 2 elements are member of period number 2. So in same period, left to right, with increase in atomic number and nuclear charge of elements, whenever nuclear charge increase, then atomic size become decrease. So due to decreasement of charge, more electronegativity occurs, having a small size. So nitrogen is more electronegative than carbon because size of nitrogen is very less than carbon. Now this is the order of electronegativity. After that we will discuss about in case of silicon and phosphorus, atomic number 14 and 15, atomic number 14 and 15 respectively, and last cell is 3s2, 3p2, and 3s2 and 3p 3s2 and 3p4. And in case of phosphorus, 3s2 in case of phosphorus, in case of silicon and phosphorus, 14 and 15 atomic number respectively. So last cell configuration is 3s2 and 3p4. 3s2, 3p5. Now these elements are member of period number 3. So in same period left to right with increase in nuclear charge and atomic number, whenever we check left to right order of element, then with increase in atomic number atomic size become decrease, with decreasement of atomic size electronegativity become increase. So correct order of electronegativity is here. Potassium is more electronegative than silicon. Now in period number 2 and 3, top to bottom with increase in atomic size and electronegativity become decreases. So the correct order of electronegativity is silicon. Okay, less electronegative, after that more electronegative phosphorus, and carbon is less negative, after that more negative is nitrogen. This is the correct order of electronegativity of elements. So according to given options, option C is correct. Now question number 6 is based on calculation of isoelectronic species. Okay, this question is completely based on totally. Now this question is based on topic isoelectronics. According to this question, the ion that is isoelectronic with CO, these 4 options are given. Which one is correct? Now what is isoelectronic? Isoelectronic means iso means same. So if same number of electrons are present in 2 or more than 2 species, 2 maybe atoms, maybe molecules, and maybe ions, they are known as isoelectronics. Okay, now in question CO is present, so carbon monoxide C plus O, atomic number 6 and 8, so number of electrons is 6 plus 8, 14. Now we can check in these options. Option A is Cn, A is Cn single minus, so carbon plus nitrogen single negative, atomic number 6 and 7, so electron is 6 plus 7 plus 1, 8, so 7 plus 1, now 14. So option A is correct because 14 electron present in CO and 14 electron present in Cn minus, so option A is correct. But we can check some other options. In case of O2 single plus, O plus 8 and 8, now electron 8 plus 8 minus 1, 7, 15 electron is here. Now in case of O2 single minus, O plus O single minus, 8, 8, now 8 plus 8 plus 1, so electron is 17. Now another case, N2 single plus N plus N plus 7 and 7. Now electron is 7 plus 7 minus 1 6, 13 electrons. So according to given options, in CO 14 electron is present, but in all options A B C D only A option is correct, because in Cn minus cyanide ion 14 electron is present. So option A is correct. You can take a screenshot. I am going to solve question number 7. Question number 7 is, which of the following is soluble in water? These 4 options are given. Actually water is polar solvent, and water have tendency to form H bond. So only polar solute, only polar solute soluble in water, and those molecules which form H bond, okay, soluble in water. So one by one we can check. Option A is CH2. Option A is CH2. CH2 is non-polar. Okay. After that, we can apply phone formula: fluorine, oxygen, and nitrogen. They are H bond maker. And in any molecule, if in any molecule fluorine, oxygen, and nitrogen present in any hetero molecule, then molecule may be soluble in water, mostly soluble in water, mostly soluble in water, mostly soluble in water. So on the basis of H bonding concept, we can find here fluorine, oxygen, nitrogen not present, here oxygen is present, so oxygen is H bond maker, so alcohol is easily soluble in water. But bulky alcohol not soluble, slightly soluble, or not soluble in water. Okay, so here ethyl alcohol is soluble in water. CCl4 is also non-polar. Okay, and CHCl3 also not soluble in water. So option B is correct. You can take a screenshot. Now I am going to solve question number 8. According to question number 8, the pair in which ions are isoelectronic with aluminum cation each. These 4 options are given, and in these 4 options, which set of cation and anion is isoelectronic with aluminum cation? Now, what is isoelectronic? Isoelectronic means same number of electrons in 2 or more than 2 atoms, molecules, or ions. Okay, now all are ions. Now in case of aluminum cation, atomic number 3, electronic configuration 1s2, 2s2, and 2p6. Electron is 13 minus 3 is 10. Okay, now in case of option A, bromine, atomic number 35, and due to presence of single electron, electron is 35 plus 1, 36. In case of beryllium, atomic number 4, due to presence of 2 positive charge, electron is 4 minus 2 is equal to 2. Now this option is wrong because both are not isoelectronic. And option B is chloride, chlorine atomic number 7, electron is chlorine atomic number 17, then electron is 17 plus 1, 18. In case of Li single plus, atomic number 3, electron is 3 minus 1 is 2. So option number D is also wrong. In case of option number C, sulfide, atomic number sulfur is 16, electron is 16 plus 2, 18. Now in case of potassium, atomic number 19, electron is 19 minus 1 is 18. So both are isoelectronic, but these two ions are not isoelectronic with aluminum. Now in case of D oxide, atomic number 8, electron is 8 plus 2, 10. And in case of magnesium cation, atomic number 12, so electron is 12 minus 2 is equal to 10. Now in case of aluminum cation, atomic number 13, due to presence of 3 positive charge, electron is 13 minus 3 is equal to 10. So option number D is correct, because 10 electrons are present in these 3 ions. Now option D is correct. You can take a screenshot. Now I am going to solve question number 9. According to question number 9, among the following basic oxide is, 4 options are given. Which oxide is basic nature? Show. Now answer is, the basic formula is, whenever metal oxide react with water, then metal hydroxide is obtained. Whenever non-metallic oxide react with water, then acid is prepared. Now according to this formula, first option is non-metal oxide, sulfur is non-metal oxide. After react with water, acid is prepared. Due to requirement of basic oxide, here silicon oxide not give basic oxide. Calcium is metal oxide, so whenever calcium oxide react with water, then calcium hydroxide means basic oxide is prepared. So option C is correct. After that, aluminum trioxide is also metallic oxide, but due to amphoteric nature, here only basic oxide is required. So due to amphoteric nature, this option is not correct. C option is perfectly correct. You can take a screenshot. Now I am going to solve question number 10. This question is based on nomenclature of IUPAC nomenclature of elements. Now according to this question, the IUPAC nomenclature of the element with electronic configuration radon 5f14, 6d1, 7s2 each. 4 options are given. So now the answer is, electronic configuration radon having atomic number 86 and electronic configuration 5f14, 6d1, 7s2. Okay. Now Z is 86 plus 14 plus 1 plus 2 is equal to 103. This is atomic number of element. Now from IUPAC convention, digit and IUPAC name of digit is, for 0 nil, 1 is un, 2 is bi, 3 is tri, 4 is quad, 5 is pent, 6 is hex, 7 is sept, 8 is oct, and 9 is ENN. Okay, 9 is ENN. Now according to this convention, we can solve this question. The formula is first digit plus second digit plus third digit and IUM. Okay. Now for 103, atomic number, IUPAC nomenclature is 103. 1 means un, 0 means nil, and 3 means tri. Okay, and now IUM. So due to presence of 2i, we can write un, nil, trium. Okay, and we can check options now. Un, nil, trium. So option D is correct. You can take a screenshot